This is a challenging problem. This problem comes after quite a bit of experience that we've had playing with higher order polynomials, doing long division, using the complex conjugate root theorem, using synthetic division, and so on to work this down into factored form. Now, the question I'm going to pose to you right at the beginning here is this. What polynomial gives these two roots? One of those roots you were given, okay? This root, the problem told you. But the next root, right below it, the x2, I got by knowing what the complex conjugate root theorem says, which is basically this. If you have a 1 minus 2i, then the other root has to be a 1 plus 2i, right? You just switch that sign. So what polynomial gives these two roots? What you have to do is come over here and do a little multiplication. Okay, if you notice, I said x minus x1 times x minus x2. That's the polynomial that gives x1 and x2 as roots. And if you look at what I did here, I sort of went through this multiplication process where I started using those roots I was given, 1 minus 2i and 1 plus 2i, and I plugged them in and patiently worked through the algebra until I got this as my answer. Now that, of course, it's not the answer to the whole problem, but that is the irreducible quadratic factor right here. Okay, so that's my x squared minus 2x plus 5. That's how you find it. Feel free in this video to pause in certain places and look through that algebra until you understand what's going on. This has to be kept to 5 minutes, but there's a lot more than 5 minutes of work here. Now, next part. How do I find the reducible cubic factor? Well, what I have to do is divide, right? I have to divide this gigantic fifth order polynomial by this irreducible quadratic factor. And if I divide the fifth order by the second order, I should get a cubic polynomial, a third order polynomial. And you can see that way over here. Okay, I'm going to have to zoom out for this guy. So there's a little bit of long division involved in this problem. I'm going to pause right here for a moment. You should pause if you want to work through how long division operates. Just remind yourself of this process. But what you get at the end, whoops, didn't want to do that. What you get at the end is this. This is called your quotient. Okay, and this down here is your remainder. Now, if the remainder is 0, you are good to go. You found a true quotient. If your remainder is not 0, in this problem, this doesn't go for all of life, but in this problem, the remainder has to be 0. And if it's not 0, you made a whoopsie. So you'd have to go through and find the mistake. If I had to guess what your mistake was without seeing it, I'd say either you made a mistake in all of this stuff, that's possible, or you made a mistake in a simpler part kind of early on over here when you were finding the irreducible quadratic factor, right? Maybe your mistake was in this guy. Those are the two most likely places. So what I'm going to do is I'm going to put that cubic factor right here, this 4x cubed minus 7x squared minus 5x plus 6 that I found through long division. And now we get to this next part, which is find all the possible roots of f of x. Okay, I can ignore the irreducible part. I'm just looking at the cubic portion now. And if you remember what we do here, this is the P's and Q's business. Remember the rational roots theorem. I'm going to take all the roots of 6, right? This number at the end right here. I'm going to take all the roots of that, which is 1, 2, 3, and 6. I should say factors. And I'm going to compare that to all the factors of 4, right? 1, 2, and 4. Don't forget there's plus and minuses. And there's a lot of possibilities. What this is going to turn into is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 1/2, right? And so on and so on and so on. And you have to guess all of them using synthetic division. I am not patient enough to go through that with you, and I don't think you are either. Let me just remind you of the synthetic division process and how this works. So I have my coefficients, 4, -7, -5, and 6 of that cubic function. I'm going to guess -1 because I know that works. So I get 4, -4, -11, +11, +6, -6, and 0. Another remainder of 0. So what that means is this is going to give me x plus 1, okay, and 4x squared minus 11x plus 6. Now compare those coefficients. I want you to really be sure you see where these things are coming from. Okay, this -1 produced this factor of x plus 1. And this answer right here, these coefficients, produced this factor right here. So you do likewise with your problem, and you should be able to work this down into factored form.